Today we are doing 1.7. We are solving inequalities. This goes on page 26 of your notebook. Page 25 we will do later. So remember 25 goes with 26. It's the extra problems you do on your own. So solving inequalities. The great thing about solving inequalities is that you get to use the exact same steps as solving equations. Exact same steps as solving equations. There is one difference. So really big I wrote except when you multiply or divide by a negative, the inequality flips. Okay, so when you multiply or divide by a negative, the inequality flips because multiplying or dividing by a negative changes all the signs on the other side. So all the positives become negative, all the negatives become positive. So we have to flip our inequality. So the first inequality that we are going to review before we do examples is less than. So make it nice and big. Less than I always remember because it looks like a, well, no, I think it looks kind of like an L. So like a narrow L. So less than, you're just writing this on your Post-it note. On top. Because underneath you're going to do an example. Okay. Really big I wrote less than because that's how we read it. Less than symbol looks like this. And when we graph it on the number line, we graph it with an open circle, and all the solutions are to the left. And we're going to do an example with a number line. So make sure you give yourself enough room to do a number line. Okay. So what do I mean by open circle? The circle or the dot on your number line, which indicates where your answer starts or the end point. If we have just a less than, we make it open because that means that our end point is that number, but we can't actually use that number as a solution. So for example, x less than 3. If I plugged in 3 for x, would I get a true statement or a false statement? False, because is 3 less than 3? No, they're equal, right? So I cannot use 3 as a solution. So when I'm graphing x less than 3 on the number line, let me zoom in just a little bit. So when I'm graphing x less than 3 on the number line, at 3, I put an open circle, which means 3 is my end point, but I can't actually use it as a solution. And then on the number line, all of the numbers that are smaller than 3 are as I go to the left, right? 2, 1, 0, -1, -2. So you're going to draw an arrow to the left, which indicates that any number less than 3 at that endpoint actually could be a solution for x. So how many solutions do we actually have? An infinite amount, because we keep going into the negatives forever and ever and ever.
Because the numbers never end.
Because the numbers never end. So the other kind of inequality that we looked at was greater than. When we graph greater than, we also have an open circle, but our solutions go to the right. So the example we are going to graph is x greater than 0. Okay. Okay, so if we are graphing x greater than 0, we put an open circle around 0 because we can't actually use that as an answer. And all of the answers that are greater than 0 are going to the right. So the arrow just means that that's anything that lies on that line could be a solution. So the next inequality, less than or equal to. It basically looks like a less than, and then we have half an equal sign underneath. Okay? If we are less than or equal to, we get to use a closed circle because our endpoint can be used as a solution. So that's what the closed circle means. And then it's less than, so your solutions are going to be going to the left. So the example I'm going to do is x less than or equal to, let's do 10. So because on my number line it goes all the way to 10, I made each dash count as 2, and I just labeled the 10. You don't have to label each individual one. If you want to, that's fine. You don't have to. So because I went 2, 4, 6, 8, 10, I just labeled my last one 10. So on this one, 10 is my endpoint, so I get to use a closed dot because the solution could also be equal to 10. So the closed dot means that I can use 10 as a solution. But then all the rest of my solutions are to the left. Okay? So the closed dot means you can use the endpoint, so it includes the endpoint, and then everything else, all the other solutions are to the left. Last one would be greater than or equal to. Looks like a greater than with half an equal sign. Because it has the equal, you do get to use a closed circle. Solutions then are after the closed circle are to the right. So the example I'm going to do is x greater than or equal to negative, let's just do 3. So because I am greater than or equal to negative 3, I'm going to put my endpoint at negative 3, and I'm going to do a closed circle because I can use 3. And then everything that's bigger than 3 goes to the right because that's the direction that my numbers get larger. All right, so like I told you guys, we are going to do our examples just underneath the Post-it notes. So underneath the less than, flip it up, and let's write example 1. Let me zoom in for you guys. So example 1, we are going to solve 9 plus 4t less than 21. And we are going to graph it. Don't write giant. So I told you guys that to solve, we're basically going to use the exact same steps that we use for solving equations. So we want to get all of our variables on one side, which we already have them, right? 4t is already on the left. So how would, what would I do first? Subtract. Subtract what? 9. So subtract 9 from both sides. Because 9 minus 9 gives me 0. And that leaves me with 4t less than 21 minus 9, 12. Does subtracting flip the inequality? No, just multiplying or dividing. Okay? So just multiplying or dividing. What would you do next to solve for t? Divide by 4. That's a positive 4, so we do not have to flip the inequality. But we end up with t is less than 3. That's your algebraic solution. So to graph it, make your number line. I'm going to put 0 in the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You might have to change your scale depending on what your numbers are. And then t less than 3, is that going to be an open dot or a closed dot, guys? Open at 3. And less than means we're going to go to the left. Okay? So underneath the greater than, let's do example 2. And the example is 3 times t plus 1 minus 4t is greater than negative 5. So guys, for this one, when we were solving equations, what did you do as your first step? Distribute. So 3 times t would give me 3t plus what? Plus 3 minus 4t greater than negative 5. And then we would combine like terms. What's 3t minus 4t? Negative 1t, or you can write it as just negative t, plus 3 greater than negative 5. And then what would I do?
Subtract 3.
Yep, subtract 3. Okay, so that's negative t greater than negative 8. On your homework, when a couple lessons ago, when we were doing solving for our variables, and I got a lot of you that gave me like negative x equals negative 3. Am I asking you to solve for negative x, or am I asking you to solve for positive x?
Positive.
Positive x. So this is actually a negative 1 times t. So in order to get rid of that negative 1, I would have to divide both sides by negative 1. Because negative 1 divided by negative 1 gives me positive 1. But, I just divided by a negative. So right next to it, let's write flip to remind ourselves. So that inequality is no longer greater than, it is now less than positive 8. Do you mean t squared?